the normal distribution. It's beautiful and very useful in statistical theory. It also describes quite a few distributions that happen naturally in the world. Here's the normal distribution. The best way to think of that is probably as a pile of an enormous number of potential observations or data points. In fact, in theory, an infinite number, piled up round near the centre here, and in theory continuing forever with very, very thin tails off in both directions. The total area under this curve, like all probability distributions, is 1 and corresponds with probability. This vertical axis of probability density, well, don't worry about that label. The important thing is area under this curve corresponds to probability. Here's the normal distribution at the normal page in ESCI. I can turn on the mean. The axis here is Z or Z, so this is actually a standardized normal distribution. And here are the units 1, 2, 3, -1 and so on in units of standard deviation. I can turn on the Z lines like this. Then our rules of thumb say that the area under the curve between 0 and 1 is approximately 1/3 of the total, another third here. And another rule of thumb is that between Z is -2 and 2 is about 95% of the total area, so about 2.5% beyond 2 and another 2.5% beyond -2. Now I can turn on another axis, the x-axis, which is showing in this case IQ scores, so with mean 100 and with standard deviation of 15. And so as you use those formulas to translate backwards and forwards between x and z, then you are simply translating between this upper axis and the lower axis. So what proportion of people would you expect to score an IQ score above 130? Translate that down here to Z of 2, and we know the area is here roughly 2.5%, so roughly 2.5% of people would score an IQ greater than 130. Now let's turn off the x-axis and mark tail, one tail, and we have a cursor down here that we can adjust. If we turn on areas, the cursor is set here at Z of 2, and so the area beyond it is 0.0228, and to the left 0.9772, roughly corresponding to our 2.5% here. Let's move this down to Z of 1. There we are. Ooh, a bit too far. Z is 1. 0.84 is the area here, so 0.5 is the area up to 0, and so 0.34 the area in there, roughly corresponding to our rule of thumb of about 1/3 of the area in here. Let's find more accurately the critical value of Z for 95%. I want to have two tails and move the cursor out until the area between the two cursors here is 0.95. I've overshot. Let's come back a little bit. There we go, 95% there, two tails 0.05 or 2.5% each of these blue areas, and the critical value of Z or Z is 1.96, one of the numbers to remember. Now let's do this for 99%. Move this out. And there we go. We've got 99% here, the two tails just 1%, 0.01 area, and the critical value down here is 2.58 when rounded. So between Z is minus 2.58 and plus 2.58, we have 99% of the area under this normal distribution.